bring the prosperity of Shanghai to the port of Ningbo. Engineers are constructing a 36-kilometer-long bridge across Hangzhou Bay. For the project to be a success, the huge container ships that use Ningbo port must be able to pass under the bridge. This will require giant spans 450 meters wide and 45 meters high over the deep water shipping lanes. But these towering bridge sections create a whole new set of problems when the environment is factored in.
Another major design challenge was to design this bridge, the navigation spans for typhoon wind conditions.
Hangzhou Bay is home to some of the most violent storms and typhoons on the planet.
Since construction for the bridge started in November 2003, a 2-year time span, we have encountered 11 typhoons.
Typhoon winds can reach speeds in excess of 170 kilometers an hour, causing extensive damage to everything in their path. The enormous spans needed for container ships to pass under Hangzhou Bay Bridge will be prone to wind. Here, the distance between the piers is so great that the weight of the span must be supported by cables from above. And cable-supported bridges are especially vulnerable in high winds.
Cable-supported bridges are very flexible. What that means is that due to wind traveling across them, like an airplane wing, they will tend to oscillate. Wind tunnel testing and other criteria have to be taken into account in designing for wind stability.
To find a design that could stand up to the extreme conditions in the bay, the wind engineers built numerous models of the bridge, then subjected those models to the typhoon-strength winds the real bridge will have to endure. Getting the design right is crucial. If they don't, the results could be devastating. The Tacoma Bridge in Washington State in the United States is a classic example of what can go wrong. The bridge was nicknamed Galloping Gertie because from the moment it was finished, it was unstable. But in November 1940, high winds hitting the extremely flexible bridge caused a bizarre twisting motion. This unusual pattern grew steadily worse until finally the cables broke and the bridge self-destructed.
That is what we need to ensure will not happen on a bridge. So we make the bridge by shaping its edges and making its shape such that it will be aerodynamically stable.
After extensive wind tunnel testing, the engineers come up with their final design. A cable stay system supported by a 202-meter-tall A-shaped tower at the south end of the bridge, and two 187-meter-tall diamond towers at the north end. The cables will support the giant spans, and the triangular shape will increase the stability of the towers in high winds. The result? Navigation spans stiff enough to resist typhoon-strength winds. But coming up with a design that can stand up to the environment is not the same as building it. High above the raging currents of Hangzhou Bay, the workers at the bridge must battle the extreme elements every day. It's not work for the faint-hearted.
The workers need to overcome a frightened state of mind. Most of our workers hired to work around these parts have no experience of working near the sea and have never experienced typhoons before.
It's not just the workers' state of mind that concerns the team. Workers' safety and the completion of the project are in jeopardy.
The construction program is 5.5 years long. That may seem reasonable, but every year the weather window suitable for construction is only around 200 days. So just to think we have to squeeze all construction activities into 200 days a year, That is a great challenge.
The team has to take decisive action to ensure the safety of the workers and keep the project on schedule. Because when severe conditions take hold, work at sea comes to a halt. They come up with an ambitious plan. If it succeeds, it will create a safe work environment and keep the project on track. The plan? To build the world's longest sea bridge on land.
Once we move the fabrication process and build the bridge on ground, so to speak, and try to find a way to erect it up there in the air, we would have removed a lot of headache, and we're also less prone to the forces, the elements of nature.
When severe weather conditions halt construction at sea, prefabrication can still take place on shore. Vast prefabrication factories, stretching as far as the eye can see, are set up on both sides of the bay. These manufacture the giant girders required for the construction.
What that means is that you get really good quality product built in factory conditions, under controlled conditions. They can be made, then be brought to site and then assembled.
Traditionally, prefabricated girders are made in a series of pieces and are assembled together at the bridge site. But to reduce the time at sea, engineers use a clever technique on a scale never attempted before. The giant girders will be cast in a single mold.
The technique has been used previously. First time it was used was on the Taiwan high-speed railway. But those were much smaller units. But what is interesting here is that this is by far the largest unit in the world.
These massive girders are up to 70 meters long, 16.5 meters wide, and weigh a staggering 2,200 tons. Lying on top of the piers, they create the tabletop structure which will support the road. To make the largest girders, 200 tons of steel rebar is tied and welded together. It takes 65 workers just under a day to produce one of these massive steel skeletons. Once complete, the steel frame is transferred to the mold using a giant crane. The drive mechanism uses a unique synchronized rotation system, allowing it to turn on a dime. The crane maneuvers into position and carefully lowers the steel frame into the mold. Engineers check the exact positioning of the frame and make final adjustments. Each girder soaks up a whopping 830 cubic meters of concrete. To prevent cracking, they pour the concrete in one go using 4 pumps and a constant supply of concrete. It's an impressive feat of coordination and takes 150 workers 8 hours to cast one girder. It's going to take over 1,000 prefabricated girders to complete the 36-kilometer-long Hangzhou Bay Bridge. But building the bridge will require moving these giant jigsaw pieces out to sea. It's an engineering obstacle course, and to succeed, the team will have to take bridge building technology to a whole new level.
The Mythbusters are back, this time by